Hey everyone, welcome back to Bugnojutsu. Today we're diving into a really interesting backtracking problem from LeetCode, the 24 game. This one is a bit tricky but also fun because it combines recursion, number operations, and some clever thinking. By the end of this video, you'll have a crystal clear understanding of how to approach this kind of problem and why backtracking is such a powerful technique. So, let's get right into it. We are given 4 cards, each with a number between 1 and 9. Our goal is to determine whether we can arrange these numbers with the operators plus, minus, multiplication and division and parentheses in such a way that the expression evaluates to exactly 24. There are a few important rules to keep in mind. First, division here is real division, not integer division, which means we can end up with fractions. Second, we cannot just concatenate numbers, for example, turning 1 and 2 into 12 is not allowed. And third, we have to use all 4 numbers exactly once in our expression. If there's at least one valid arrangement that gives us 24, we return true, otherwise false. So in short, this is a search problem where we need to explore different combinations of numbers and operators to see if 24 can be achieved. Let's take an example. Suppose the input is 4, 1, 8, 7. Now, one possible solution here is 8 minus 4 times 7 minus 1. Breaking it down, 8 minus 4 gives 4, and 7 minus 1 gives 6. Multiply them together, and we get 24. So in this case, the answer is true because there exists a valid arrangement. Not every set of numbers works out this nicely, though. For some combinations, no matter how you arrange the operations, you can't reach 24. That's why our solution needs to systematically check every possibility. The way I approached this problem is by using backtracking. The main idea is to repeatedly pick 2 numbers from the list, combine them using one of the arithmetic operations, and then replace those 2 numbers with the result. This reduces the list size by 1 each time. We keep doing this until we're left with only a single number. At that final step, if the number is close enough to 24, we return true. If not, we backtrack and try other combinations. So, for every pair of numbers, we generate possible results like a plus b, a minus b, b minus a times b, and both possible divisions if the denominator is not 0. Then we continue recursively with the smaller list. This recursive search ensures that we don't miss any possible arrangement of operations, since we are exploring all paths. The use of backtracking here is very natural because we're exploring one path, and if it doesn't work, we backtrack and try another. One key insight is that floating point precision matters. Because we are dealing with divisions, results like 23.999999 might appear, which are technically not equal to 24 but should be treated as valid. That's why we check if the number is within a very small tolerance, like 1e minus 6, instead of checking exact equality. Another insight is that this problem shows the power of recursion and backtracking. Even though the problem space looks large, by systematically breaking it down into smaller subproblems and exploring all paths, we can reach a correct answer in a very structured way. Now let's talk about complexity. In terms of time, this solution grows very quickly because at each step we are choosing pairs and trying multiple operations. Roughly, it can be considered exponential, around n factorial times 4 power n, in the worst case. But since n is fixed at 4, the input size is small, and this is perfectly fine for our problem. For space complexity, the main cost comes from the recursion stack. In the worst case, we go down 3 recursive levels, because we reduce 4 numbers to 3, then 2, then 1, so the space complexity is about n, which is very small. In problems like the 24 game, always shrink the problem step by combining 2 numbers with all possible operations until only one remains to check against the target. Since subtraction and division depend on order, both directions must be tried. Also, handle floating point precision carefully using a small tolerance like 1 times 10 to the power of -6 instead of strict equality. So that's how we solve the 24 game problem using backtracking. It's a great example of how recursive thinking can be applied to seemingly complex problems. If you enjoyed this explanation, don't forget to like the video and subscribe to Bugnojutsu for more problem-solving tutorials and algorithm deep dives. And if you have any doubts or want me to cover other tricky problems, let me know in the comments below. Thanks for watching, and I'll see you in the next one.